Hello learners, here Mr. Jim, and we're going to be talking about the relationship between the strength of the intermolecular forces and some physical properties. Now, the physical properties we're going to be talking here are going to be the boiling point, and the melting point. These two terms, we already done it in grade 10, okay? But we are going to be talking about melting point and boiling point. So let's begin by writing down the definition of boiling point and melting point. So first, boiling point. Boiling point is the temperature. It's the temperature at which the vapor pressure of a substance is equal to the atmospheric pressure. That definitions we are going to go into more details later on when you are in grade 12, but for now you have to learn the definition of boiling point. Now very important to know, the stronger the intermolecular force, I'm going to use the abbreviation, the higher the boiling point. The stronger the intermolecular force, the higher the boiling point. So substances that have stronger intermolecular forces will have higher boiling point. That is related to boiling point. Now, the definition of melting point says that the temperature is the temperature at which the solid and liquid phases of a substance are at equilibrium. And we also have to know that the stronger the intermolecular force, the higher the melting point. The higher the melting point. So, if the intermolecular forces are stronger, the substance will have higher boiling point as well as higher melting point. Now, there are going to be three factors that are going to affect the strength of the intermolecular forces, and therefore they will also affect the boiling and melting point. Now, those factors that affect the strength of the intermolecular forces are going to be the following. First of all, the size of the molecule. Size of the molecule. The bigger the molecule, the stronger the intermolecular forces. We're going to see to this one just now. Okay. Second factor is going to be the shape of the molecule. And the final one is the polarity of the molecule. So the size of the molecules, the shape of the molecules, and the polarity of the molecules. Those are the three factors that are going to indeed affect the strength of the intermolecular forces and therefore the boiling and melting point. So let's first of all start one by one and see how those different factors affect the strength of the intermolecular forces. Now, what do we have to learn about size? The larger the molecule, the more site for the formation of London forces. So the stronger the intermolecular force. What do we say here? The larger the molecule, the more sites for the formation of London forces, the stronger the intermolecular force. So if the molecule is large, what is going to be affected is going to be affected the London forces. So the larger the molecule is, the more London forces the molecule will can form with another molecule. Okay, and we can actually look at some examples. Okay, let's analyze this example. Now, in this example, we have three substances. All of them are made from carbon and hydrogen only. You will learn about that more in grade 12. It's not important now. The names are propane, butane, and this one is propane, butane, and pentane. This one is a mistake here. Let's just fix this name quickly. It is pentane. Okay, so we have those three different substances. We have here the boiling point of each of them. You can see that the boiling point is increasing from propane to butane to pentane. Now, what is the trend here? The trend is that the molecule become larger. You can see here 3 carbons, but here you can see 4 carbons, and here you can see 5 carbons. So the molecule is becoming larger and larger. And now as the molecule becomes larger and larger, so does the boiling point increase. So let's first of all analyze something. This one is a non-polar molecule. This one is a non-polar molecule. And this is a non-polar molecule. So all of them are non-polar. Therefore, this comparison is, we can make it. We cannot compare a polar with a non-polar. And all of them will have London forces. So London forces are the forces that keep the molecules of propane together, and are the forces that keep the molecules of butane together, and are the forces that keep the molecules of pentane together. So what we can say, as this molecule become larger and become longer, the strength of the intermolecular forces is also stronger, or is higher. So there can be more site for London forces, and therefore the intermolecular forces are stronger. So we can see here that pentane have the strongest intermolecular forces of this group, and propane have the weakest. The weakest intermolecular force in this group. What type of intermolecular force? London force. You have to be specific. So in this question, if they said that this is compound A, compound B, and compound C, what trend do you see here? The molecules from A to B to C are becoming larger. You can see this molecule is bigger than the other one. Therefore, there is more site for London forces. Remember, the molecule, the intermolecular force that is going to be affected here is the London forces, only the London forces. If the molecule is becoming bigger, only the London forces is going to be affected. Here it is rated, only the London forces will be affected. So I hope this is clear. Let's go to the second factor, which is the shape of the molecule. So the other point is shape of the molecules. Okay, so let's see what happened here. Okay, so what we have to know here, linear molecules have larger surface area than spherical molecules. Now, what is the relationship here? The same. A large surface area will have more space for London forces. will have more space for London forces. So, larger surface area have more space for London forces. That is important to know. And the same, see here, more space for London forces will lead to stronger intermolecular forces. We will have stronger intermolecular forces. Stronger intermolecular forces. So let's see one example as we did before. Okay, in this example now, what we have three other compounds. These are organic compounds. We are not going to be doing this, but you need to know what is happening still, okay? So we have some substance called pentane. We have a second one called... So here we have those three compounds and the boiling point of each of them. Now, note the following important thing here. All of the compounds will have 5 carbons and 12 hydrogen. All of them. So all of them will have the same mass. All of them will be non-polar. And all of them will have London forces. So the only difference is the shape. The first one is straightforward, it's one straight linear molecule, but now the second one is not so linear. You can see a small part that is coming out here. And the last one is even more spherical, it's less linear. Therefore, that will affect the strength of the intermolecular forces. There are more spaces for the London forces in the first compound than in the second, and in the second and the third. So that will affect the strength of the intermolecular forces. There is more spaces for London forces in pentane, and therefore have a higher boiling point than the other ones. The other factor, the last factor, I hope that you understand that one. You can always ask questions. You have any, you can write a comment. And the last one is the polarity of the molecule. But this one here is quite easy. Remember, the polarity of the molecule have to do with the type of intermolecular forces. Substances that have hydrogen bond will have stronger intermolecular forces than dipole-dipole, and dipole-dipole will be stronger than dipole-induced, and dipole-induced will be stronger than London forces. So that is everything related to the relationship of the strength of the intermolecular force and physical property. Now, what you need to know. The stronger the intermolecular force, the more energy is needed to break the intermolecular force. And because there is more energy needed to break the intermolecular force, there will be higher boiling point and melting point. This is everything related to the strength of the intermolecular forces versus physical properties. This is for grade 11. It is applicable for grade 12 as I recalled, and is for grade 11. Thank you for watching. I hope you understand, and good luck.